Hello. Believe it or not, this is actually the second time for me doing this. I'll just, right off the bat, so what I decided to do is to try to help you guys out with a graph, because I've heard a bunch of students are a little confused on how to make a graph using a spreadsheet. So this is pretty much just a tutorial on how you can use a spreadsheet. Now, ideally, I would recommend using Excel, and I'll show you why. If you have Microsoft Excel will make this a lot easier. You just put your data in like this, and then you want weight and displacement. That's the graph that they're looking for in this particular lab. You go to Insert, Chart, Scatter Plot. That's the graph. There's quick layouts that make your life pretty easy. You want to have some kind of, yeah, that's probably the best one for this one. The one's got the trend line, right? And then that's pretty much it. You would just have to kind of mess with your headings a little bit. You know, call this the what's on the x-axis in this case? Our weight. We control the weight in newtons. And our y-axis was the displacement, and that was measured in meters, right? You could copy this out. I should call this thing. It's spring displacement versus force applied, right? You can copy this, and you might be able to just plop it right in here. And there you go, right? That would be it. That's doing the graph. Now, if you don't have Microsoft Excel, after playing around with it, I've decided Google Sheets is trickier to use, but it's not impossible. So let's say you want to make the graph using Google Sheets. So first thing you'd have to do is Insert, Chart. Now the type of chart we want is a scatter plot, right? And then we have to choose the data we're going to use. So the data range is the y-axis, and in this case our y-axis is the thing that we didn't have control over. And in this case we didn't control the displacement, so just, of course, it sometimes gives you problems, which is part of why Excel's easier. Highlight the column for your y-axis, and that goes in. And then for your x-axis, highlight the columns, and there you go, right? So still not quite right yet. Have to fix a couple of things here. You have to, this is where it gets annoying. Create grid lines, right? You need vertical grid lines of like a good splashing like that, and then horizontal grid lines 10 across like that. You also need to have a trend line. Trend line's super important for this lab. It's under series, so you go to series, point shapes a circle, that's fine, doesn't matter. Error bars, right? So there is some error in our displacement. Our displacement's error was about 1/3 of a millimeter, so 0.0003. Right, and that looks about right. We want to have a trend line. That trend line matches and it falls within the error bars, which is good. And you want to have a label, and the label's going to be the equation, right? So now the graph's starting to look better. Then start adding titles. So the horizontal axis title was our thing we controlled, which was the weight. So I type in the weight in newtons. The vertical axis title, that is the displacement. measured in meters. And then we want a title for this whole thing, which is, we'll call it spring displacement versus force applied. All right. And ta-da, there's your graph data with a linear trend line that's going through it. Now make sure you don't use connect the dots or anything like that. That would be a big problem. To put it into your lab report, click on the little triple dots, copy the chart, and paste it over here. If you're using a Google Sheets, you can actually link it so that if you make adjustments, it'll adjust it on your lab report, which can be nice, like that. Now the other thing about the graph is you're supposed to use the graph to find your spring constant. And what is a spring constant? A spring constant is the amount of force per unit stretch. Basically it tells you how hard the spring's going to pull if I stretch it a full meter, right? Newtons per meter is the unit, right? Newtons per meter. Now what we have in this graph is not newtons per meter, it's meters per Newton. And what do I mean by have? So it turns out that there's a constant proportional, like there's a proportionality constant between the line and, you know, like as I stretch it a certain amount of, as the weight is added, more stretch occurs. And you could kind of think of this line like the math equation y equals mx plus b, right? That's probably from your first year algebra class, right? In this case, for the way it's written here, it says y equals 0.0688x plus 0.00152. See, this e negative 0.3 means 1.5 times 10 to the negative third. So it's itty bitty teeny tiny and basically zero, right? But the problem with this graph is that that's the rise over the run, right? The rise in this case is the meters, and the run in this case is newtons, right? But we don't want meters. We don't want meters over newtons. Meters should be lowercase m for both things. For the spring constant, we don't want how many meters per newton. We want how many newtons per meter, right? That's the whole point of this. So what we can do is, since we know that m, right, as in the slope of this line is equal to 0.0688 meters per newton, right? We want to invert it, so we want to take the slope and we want to raise it to the -1 power. Well, that's basically like saying take 1 divided by the slope, right? Now you don't even have to use your calculator because the spreadsheet will do it for you. If you put the equal sign and then you say take 1 and divide it by 0.688, right? It'll flip it upside down. So instead of being meters per newton, it becomes newtons per meter, which is what we want. So for this particular case, right, we found a spring constant of 1.45. I want to use 3 sig figs because that's pretty much what everything was measured in. So our spring constant K is equal to 1.45 newtons per meter. You should do a little more analysis, right? Like in terms of like what the error margin is for this. So plus or minus how many newtons per meter. But to do that might take a little more time, and I'm not going to dig into all that on this lab video. What I would recommend doing is maybe look up some simple online videos on error analysis, right? And if we need, we can make another video later on. Hope this was helpful in doing your lab. Have a good one.